Hello, statistics and pre-calculus. Welcome to your last video in topic 5. You made it. Today, we're going to wrap up graphing polynomial functions by learning how to go from factors to graphs. And this example can be found on page 299 of your textbook. Let's jump in. So, our task today is to sketch the graph of the polynomial function f of x equals negative x squared times x minus 4. So our solution has 4 different parts that we have to go through. The first is to determine the end behavior of our function, which, as you should remember, is determined by 2 things. 1, the degree of the polynomial, and 2, the sign of the polynomial function. So here we have a degree of 2 plus 1 equals 3, and our function is negative. So this means that we are going to have an end behavior because it's an odd number of our degree. Our end behavior will be different as x approaches positive and negative infinity. Because it's a negative function, our end behavior is, our y is going to approach negative infinity as x approaches positive infinity, which means, of course, that the opposite is true. As x approaches negative infinity, we should be approaching positive infinity. So I've already identified the intercepts here, but these can be found from our 2 factors. Our first factor, our intercept is 0, and our second factor, our intercept is 4. Now we can use this to complete the table. So we have 2 intercepts, which means we're going to have 3 intervals. The first interval will be everything less than our smallest intercept, in this case 0. Our second interval will be anything in between the 2 intercepts, so 0, less than x, less than 4. Finally, our last intercept will be anything greater than our largest interval, x greater than 4. So the sign of our constant factor is the sign out in front of the entire function, which isn't going to change, so it will be negative. Now, the sign of x squared is also not going to change, because whether or not we're multiplying or squaring a positive or negative number, the result is going to be the same. The sign of x squared will be positive. So this means that the behavior of our entire function actually rests on this x minus 4 term. So to determine the sign of the x minus 4 term at these different intervals, we're simply going to pick some numbers and plug in. For x less than 0, let's pick negative 1. So negative 1 minus 4 is negative 5, which is a negative number. Now we're going to do the interval of 0 to 4. We'll pick positive 1. Positive 1 minus 4 is negative 3. Another negative number. For x greater than 4, we'll just pick 5. 5 minus 4 is positive 1, so the sign here is positive. Now, given each of these, we can find the sign of our entire function at each of the 3 different intervals. So, to do this, we're going to just multiply the signs by each other. So a negative times a positive is a negative. A negative times another negative, however, is a positive. So, the sign of our function from negative infinity to 0 is positive. We'll do this for our next interval. Negative times positive is negative. Negative times negative is positive. So the sign of our function for 0 to 4 is also positive. Finally, for all values greater than 4, negative times positive is negative. Negative times positive is negative. This means that from negative infinity all the way to 4, we're going to be above the y-axis. And for all values of x greater than 4, we're going to be below the x-axis. Also, we know that we're going to have 2 x-intercepts at 0 and 4, and we know one of these intercepts, 0, is going to be a point of tangency because this number here is squared. So let's go ahead and try and graph our polynomial. So the first thing I want to do is actually figure out the place where my 2 intercepts are, which is going to be at 0 and 4. Now remember, at 0, this is going to be a point of tangency, and at 4, we're actually going to cross the x-axis. So now I just have to figure out what is happening in between these 2 points. So to do that, let's go back and look at our table. So I'm going to have positive y values at negative x values, which is also I'm also told right here. So I know that to get from a negative x value down to my point of tangency here, I have to start somewhere up here. I also know that from 0 to 4, the sign of my y value should also be positive. So of course, I'm going to start here, and then I'm going to turn around and go back up. Finally, I know that after I get to 4, I have to get to a negative y value, which means there's going to be another turning point somewhere around here so that I can cross through 4 at my other x-intercept and get to negative values. So let's see what this is going to look like. I'm going to start in the negative side of the graph and work left to right. So I have maybe somewhere right here is where I start. I then go down to 0 and then back up a little bit, maybe to right here. But now I know I have to go back down again to get to 4, and that this will continue all the way down. All right, so I have what I think is what our graph looks like here. Let's make it a little thicker so we can look at it together. So, sorry guys, I grabbed the wrong thing. So we can see that I have a graph that has 2 local maxes and mins, one of which is a point of tangency. I know that I have a graph where I am approaching positive infinity as I approach negative infinity in the x-axis, and I have a graph where I'm approaching negative infinity as I approach positive infinity in the x-axis. I also have a graph that has negative values for all x values greater than 4, and I have a graph that has positive values for all x values less than 4. All of this is what my table says the graph should look like. So this is roughly what our graph looks like for negative x squared times x minus 4. Now, I just want to note at this point that like my graph, yours doesn't have to be perfect. All that really matters is that you're making sure that you have the right number of maxes mins and your end behavior is correct and that your intercepts are intersecting the x-axis at the appropriate point. Other than that, you can kind of guess a little bit at where your y values are going to be in terms of these local maxes and mins. All right, guys, great work on topic 5. That concludes this round, and I will see you back here for topic 6.